Now let's work on some problems. If two fair coins are flipped, what is the probability of getting at least one head? Well, let's begin by writing out the sample space for flipping two coins. So it could be heads, 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 tails, tails, heads, or T and T. Now, the event A is getting at least one head. So this one has at least one H, this one too, and that one as well. So the reduced sample space for A is HH, HT, and TH. So now let's calculate the probability. In order for the event to occur, we have three favorable outcomes. The total possible outcomes are 4. There's 4 events in the sample space. So the probability of getting at least one heads when flipping two fair coins is going to be 3 over 4. 3 divided by 4 is 0.75, which means that there's a 75% chance for this event occurring. Now let's move on to part B. By the way, if you want to try it, feel free to pause the video. If 3 coins are flipped, what is the probability of getting at least 2 tails? So let's begin by writing out the sample space. So let's write what we had before. It could be HHH, HHT, HTH, HTT, THH, and so forth. So those are the 8 possible events or outcomes that can occur in this event. So now let's call the event A. We want to get at least 2 tails. So which of these outcomes contains at least 2 tails? We have 1, 2, 3, 4. So there's 4 potential outcomes that have at least 2 tails. Kind of mix my words up there. So let's write it out. It could be HTT, THT, TTH, or TTT. So the number of favorable outcomes is 4 out of 8 possible outcomes. So 4 over 8, you could reduce that to 8 is basically 4 times 2. 4 is 4 times 1. So this becomes 1 over 2. 1 divided by 2 is 0.5. So there's a 50% chance of getting at least 2 tails. Now let's move on to part C. If 3 coins are flipped, what is the probability of getting exactly 1 tail? So go ahead and take a minute and work on this example. Pause the video if you want to. So let's circle the outcomes that contain exactly 1 tail. So this is one of them. Here's the other. This is another one. And that is it. So for event A, or let's call it event C for part C, the 3 favorable outcomes are HHT, HTH, and THH. So the probability is going to be 3 favorable outcomes out of a total of 8 possible outcomes. 3 divided by 8 as a decimal is 0.375. And if we multiply that by 100, that means that there's a 37.5% chance of getting exactly 1 tail if 3 coins are flipped. So those are some simple examples of how you can calculate the probability of an event occurring. Now let's move on to our second problem. A 6-sided die is tossed. What is the probability of getting a 2? Let's begin by listing the sample space. So here's all the possible numbers that we can get. It's basically 1 through 6. Now, the probability of getting a 2 is just, there's only 1 2 out of 6 possible outcomes. So we have one favorable outcome out of 6, and 1 over 6 as a decimal is basically 0.16 repeating. If we multiply that by 100, but first let's round that to 0.167. So this is approximately 16.7%. So that's the probability of getting a 2 tossing a 6-sided die. Now what about part B? What is the probability of getting a 3 or a 5? So we have 2 favorable outcomes out of 6, so it's going to be 2 over 6, which if you divide both numbers by 2, you can reduce that to 1 over 3. So this is basically 0.3 repeating, so that's a 33.3% chance of getting a 3 or a 5. Now what about part C? What is the probability of getting a number that is at most 4? So let's list out the outcomes that leads us to this particular event. We'll call it event C. So that is at most 4. What does that mean? So that means we can get numbers that is less than or equal to 4. So 1, 2, 3, 4. So the probability of this event occurring, we could say, let's say if x is a variable, so x has to be less than or equal to 4. That means getting a number between 1 and 4, where x is an integer. Or technically, let's say it's a natural number, because integers could be negative. So there's 4 favorable outcomes over 6. 4 is basically 2 times 2. 6 is 2 times 3. So this becomes 2 over 3, which is approximately 0.667. So there's a 66.7% chance of event C occurring. Now what about D, part D? What is the probability of getting a number that is greater than 3? So let's list out the outcomes that favors event D. So numbers that are greater than 3, that includes 4, 5, and 6, but it doesn't include 3. So the probability of getting a natural number that is not equal to 3, but greater than 3, is going to be, we have 3 favorable outcomes out of 6. 6 is 3 times 2, 3 is 3 times 1, so this becomes 1 over 2, which means we have a 0.5 chance or a 50% chance of event D occurring. So as you can see, it's not difficult to calculate the probability of an event occurring. It's pretty straightforward, but with many examples, you can see what to do. Now, what about the last part?